great meeting you students the past few weeks.
Today, we are on a reward trip to the campus observatory to celebrate our orientation work.
Astronomy used to be the case that you had to kind of look at the stars at night, but these days actually everything is computerized.
So we have something here in front of us.
So this is called a Pilkington-Gibbs heliochronometer. It's actually pretty accurate in terms of telling time. There's a date dial here. So you set this to August. We have to point this to the sun. There's a little hole in here. Okay, and the sunlight goes through the hole and you line it up on this line
but the
here.
line, okay.
And then you can read off the time here and it says it's about 2:30.
Wow.
And it's 2:33, so.
Huh.
I'll give you a tour of the observatory. There's enough openings between the clouds, we can actually look at the sun.
Oh, that's really pretty.
This is my favorite astronomy picture. So most of the bright stars you see are maybe a few hundred light years away, but then if you look at the background, especially here, you see lots of very small stars. Those are now a few thousand light years away. So the blue is caused by young stars that emit a lot of blue starlight. The red, that's purely hydrogen, and the orange is kind of larger dust grains.
Oh, this is a vibe.
Welcome to our black room. But I'm switching off the lights now, and so as you see,
Wow.
this is actually a very dark room. We'll actually turn this into a place where we can do demonstrations. How do we actually detect planets around other stars? So if we would scale the sun down to about this size, the Earth is about this big.
Oh.
Tiny
like that
little
tip.
pin of a needle. To get this to scale, I would have to go just outside the observatory.
Okay.
That's how far away the Earth is.
Okay.
To scale, the closest star would be another ball about this size. And if we want to put it to scale, where about do you think we have to put the nearest star?
Huh.
Toronto.
Toronto?
Closer?
Closer? Well, so the surprising answer is much further away. You would have to go to Winnipeg.
Oh.
Planets move around their star.
Yeah.
Every time this planet goes around, it blocks
Oh, it dims.
the star and it dims the star. That's right. This thing here is a scale model of the Kepler Space Telescope. It can only do one thing, but it does it really well, and that's measure the brightness of the star. If you see periodic dips in brightness, that's a good indication that there's
A planet revolving.
right? And so from the time it takes between subsequent dips, that's always the same. You can actually determine how long it takes for the planet to go around the star. That tells us how far away that planet is from the star.
Oh.
Now you see there's a second planet on there as well, and it's larger. It's a bit further away, and it moves more slowly. It makes much deeper dips, right? The biggest question that I think as a species we have is, are we alone? And at the same time, we're also looking for like signals from intelligent civilizations in the closest million stars. We have a different demo. I'm going to give you special glasses. So with these glasses, everything looks different. This is glowing helium gas.
Okay.
And if you look with your glasses, you'll actually see that helium does not actually emit every single color. It doesn't look like a rainbow anymore, right? You can see very distinct colors. If you compare that to Mercury, Mercury looks bluish because it has a very strong blue line and then a green and a yellow line. And again, a very distinct pattern of lines. Then there's neon.
Whoa.
Neon looks very bright and red because it can emit mostly in red, orange, yellow, and I think there's one green line as well. Okay, and then this is actually the most common substance in the universe. This is hydrogen. So you see a bit of a brighter red line and a green line. Those are the two strongest lines of hydrogen. The rest is actually contamination. What these glasses allow you to do is to actually recognize from a great distance, because every chemical element has its own fingerprint in colors.
After the tour at the observatory, we are excited to try solar viewing and stargazing.
Wish us good luck and see you in the final episode soon!